the right slide in my presentation. Bear with me, it's a bit slow. I'm going to endeavour to go through this as quickly as I can. There's quite a lot I want to cover, but I will try not to waffle as much as I normally do. So, calories, let's have a look at what they are. Now, calories, I heard that these are pesky little blighters that come along in the middle of the night and stitch your clothes up so they feel a bit tighter when you wake up in the morning. And as entertaining as that is, you won't be surprised here it's not particularly factual. So, what is a calorie? We're going to cover that today. We're going to cover where we get them from. We're going to cover calories in versus calories out. We're going to cover that every day doesn't need to be a dieting day. We're going to cover why does dieting success slow down? And then let's get straight into it. So what is a calorie? Simply, a calorie is the amount of energy needed to heat 1 litre of water by 1 degree. So whilst food has different calorific values, a calorie is still a calorie. So you could get a calorie of fat, a calorie of protein, and a calorie of carbs. And regardless of how they behave within the body, they contain the same amount of energy. So carbs are 4 calories per gram. Same for protein, and fats come in at 9 calories per gram. No surprise for anyone that's tried to fit lots of fatty treats into their day, you get a lot less bang for your buck than you do with carbs and protein. But I hear you ask, what about alcohol? And no, I don't have a problem, I just like the odd gin and tonic. Alcohol comes in at 7 calories per gram. The difference with alcohol is it's almost empty calories in that with the other macronutrients, they do things of benefit for your body. So carbs are your prime energy source. Protein is effectively the building block of life. It's what your muscles are made of, and without those you can't move. It helps repair and rebuild. It helps strip down dead muscle tissue, and it's incredibly important. Fats make up a huge amount of your body, from your brain, your nervous system, to the membrane of your cells. They also help with hormonal signalling, so they do loads of really, really good things. Whereas with alcohol, you get a fair amount of calories, but you don't get any real benefit from them. But that's how the calories break down per macronutrient. So what we're going to look at to start with is calories in versus calories out, otherwise known as maintenance. So, in and out. If your in, or what you're consuming, balances what your body is burning, you will quite simply maintain weight. So where your intake matches your activity, if we're going to look at a guy, he's called Bob, and Bob has his 2,500 calories per day, which is what is recommended by the NHS and by other big health organisations. And his requirements to just maintain is 2,500 a day, or 17,500 calories over the course of a week. So where his intake matches his outgoing, he maintains. And what we're looking at here is not only the daily amount of calories, but the weekly. So let's look at, if that's maintenance, let's look at what an energy surplus is. So an energy surplus, or gaining weight, which is where what you're consuming outweighs what your body is burning, and therefore you gain weight. So nearly 2/3 of the Western world is obese or overweight. And it is an incredibly complex area. Obesity, being overweight, being unable to control your own body weight, isn't down to one single cause. It's so complicated, and it's so complicated that even within one individual there can be different causes at different times. So we'll move on and cover this in a bit more detail, but it's incredibly complex. What we find is it's often something that we call insidious weight gain, which is where we gain a small amount of weight each year. This happens to get worse as we age, because for each year that passes, we require slightly less calories, and most people don't necessarily know this, so they're not matching what they're consuming with what they need, and so you hit a point where you get middle-aged spread, and that tends to spread further as people's calorie intake stays relatively consistent, whereas their needs actually drop. So underlying cause is different from person to person, as I've said, and they also differ from time to time within the same person. So this is a really detailed slide about what it is felt by the Obesity Society, which is easy for everyone else to say, what the potential contributors to obesity are. And this was something that was pulled together in 2015. As you can see, inside the person on the left hand side, there's loads and loads of boxes, and that ranges from biological medical reasons all the way through to psychological reasons and developmental reasons as well. You also have environmental reasons too. Then if you look at outside the person, the biological and medical reasons for obesity drop as they would. There's still some psychological stuff going on, but you look at adding economic, you look at adding the food environment in, you look at adding social elements into, and there's so many things that can impact. I'm not going to go into each of these things because I will just talk and talk and talk, but it ranges from the environment that we are in, it ranges from the availability of hyperpalatable foods, and hyperpalatable foods are the things that are very tasty, often a combination of fats and sugars or fats and salts. And those hyperpalatable foods are designed for us to want more of them because they taste really, really good. And when there's a real free availability of them and they are incredibly cheap, it becomes very difficult to resist them. So there's so many factors. If you want to talk about this in more detail, it would be my pleasure, but this just gives you an overview of some of the things that can cause obesity or people to be overweight or for people to gain weight. So first of all, let's look a little bit at insidious weight gain. So if we go back to our Bob, he's on his 2,500 calories a day. And he's maintaining from Monday to Friday, that's fine. We know that his weekly requirement is 17,500 calories. But what happens at the weekend? Who'd have thought it? He has Saturday and Sunday out. He goes out for a meal and then he goes out for drinks. Sunday he's feeling a little bit hungover, so he goes out for Sunday lunch. And Sunday lunch turns into an afternoon in the pub drinking beer. And boom, all of a sudden he has gone up by 1,000 calories per day. And 1,000 calories in the grand scheme of things isn't a massive amount. However, when you are repeatedly going over week in and week out, it adds up. So we know that Bob requires 17,500 calories per week. However, with that increase at the weekend, the calories in becomes bigger than the calories out by 2,000, and therefore his weight goes up. So big weekends can do quite a lot in terms of preventing weight loss. What you can do is you can reduce your daily calories by 500 if you know you've got a big weekend ahead. So you give yourself a calorie deficit day in and day out from Monday to Friday. And what that does is it means that you are at 5,000 calories, 10,000 calories from Monday to Friday, which then gives you more calories to play with at the weekend. And that means you've actually created a little bit of a deficit. So in theory, you could lose £7 per week. Now, a little interesting fact for you. It is thought that roughly 3,500 calories of deficit equals £1 of fat loss. As we've said before, everything is an experiment and that number is not written in stone, but it's just a rule of thumb that if you want to lose a pound over a week, you need to create a 3,500 calorie deficit over the 7-day period. So, talking of deficits, let's look at how we do that. So, energy deficit or losing weight. When what you're consuming is less than the amount your body is burning, guess what? You lose weight. Woohoo! So let's have a look at Bob again. So Bob maintains at 17,500 calories per week and generally evened out at 2,500 calories per day. So when Bob reduces his amount of calories by 500 per day, what happens is he creates a 500 calorie deficit. on a daily basis, and that means his requirement of 17,500 calories per day is bigger than his intake, which equals 14,000 calories per day. And that gives him his 3,500 calorie deficit, which gives him theoretically that £1 of fat loss. So what is being burnt is bigger than what is coming in, creates a calorie deficit, which creates fat loss. What Bob can do, if he's not satisfied with that, is he can look at reducing his calories but also increase his activity. We know that being active increases the amount of calories that your body burns, and therefore adding activity into your day as well as a calorie deficit means your body is burning more calories just to be able to function and get through the day. Therefore, you're creating a bigger deficit. So we know that Bob needs his 2,500 calories a day. So if he does 250 calories of extra activity on a daily basis, what he does is he gives himself, theoretically, he raises his requirements to 19,250 calories to maintain weight. So if he's not eating that, he's going to lose weight, which is awesome and kind of what we're here for. So what you can do is lower your intake and higher your activity level. So in Bob's case, he lowers his intake to 500 calories. He ups his activity, so he raises what his body needs by 250 calories, creating himself a 750 calorie deficit for the day. And what that means is his intake is 14,000 calories, his required calories are 19,250, which means he's creating a calorie deficit over the week of 5,250, which generally would equate to about a 1.5 pound fat loss. So, how do I burn calories? It's all very well understanding what a calorie is. It's all very well understanding that you need to, if you want to maintain your weight, what you need to do is equal what your body needs by what you're eating. And if you want to lose weight, you need to eat less. But how does your body actually burn calories? So let's have a little look. Calories in versus calories out. And we're looking at someone who's weight stable here. So, calories in is all about your diet, whether it's food, whether it's drink, what you're consuming basically adds up to the amount of calories that you are taking in. And calories out is made up of a number of factors. So we have something called BMR, which is your basal metabolic rate, and that is the amount of calories you require just to survive on a day-to-day basis. So if you were in a coma, your basal metabolic rate wouldn't drop unless you were no longer breathing independently or your heart wasn't beating independently. If you were on life support, you'd require less calories theoretically. But your basal metabolic rate is just what your body needs to function on a day-to-day basis. So that is roughly 60% of what your calorie burn is. You then have 30% of activity, and then you have 10% for digestion. So your digestion, whenever you eat something, it requires an amount of energy to process it, and that's what that 10% comes from. Providing, as we know, your calories in is the same as your calories out, you will maintain weight. So let's look at gaining weight. We've got our calories in, again, 100% diet, and calories out. Same thing. However, your calories in are bigger than your calories out, and therefore you gain weight. So when it comes to losing weight, diet, you'll notice, has got smaller. So what you're consuming is less. Your calories out is still the same that you normally would have. You've got a deficit and therefore you lose. So let's have a look at calories out and how exercise impacts on them. So what we have on the left is someone that's sedentary, and someone that's sedentary is someone that doesn't move around a lot. Generally, you would look at a sedentary person as someone that does a desk job, spends a lot of time driving, basically spends a lot of time sitting rather than being more active and moving. So, in our sedentary person, our basal metabolic rate accounts for about 75% of their calories out. Their NEAT, or their non-exercise activity thermogenesis, is only at about 7%, and their digestion's at about 8%. In an active person, this is a much bigger amount. Because you're active, your body is requiring a different amount of calories. You are burning more calories through your non exercise activity thermogenesis, and you're adding in a proportion of calories required because of the amount of exercise or activity you're doing. So, being active means you are burning more calories than you would do if you were sitting down a lot, spending a lot of time on the computer in front of the TV. So being active is good. In summary, let's skip through these bits. Okay, so let's have a look at why we are all different. I'm going to get all of these up all at once. Oh, hello, there we go. So why are we all different? If you are an active exerciser, a non-active exerciser, or a non-active non-exerciser, your basal metabolic rate is still roughly the same because your body requires the same amount of base calories to function. However, if you are both an exerciser, so you do structured sessions of exercise each regularly, as well as being active, and that isn't necessarily being active because you exercise, but keeping moving throughout each day, which is why it's a separate calorie. Your calorie needs are higher because it could be that you're a massive fidgeter. It could be that you're a stay-at-home mum and you never ever sit down because you are running around the house doing job after job after job. All of those elements impact on how many calories that you burn. So for someone that is both active during the day and an exerciser, they are going to have a much larger amount of non-exercise activity thermogenesis, or NEAT. So the more you move, the more you're burning, and then you get the exercise on top of it. So for the non-active exerciser, they're getting the amount of calorie burn through their exercise session, but their non-exercise activity calories are much lower because they aren't active throughout the day, they're more sedentary. Then you have the next person, the non-active non-exerciser. So they require less calories because they're not exercising, so that takes a chunk of their requirement out. They are often slightly more active during the day because they're not exercising, so their NEAT could potentially be slightly higher. And then you have a yo-yo dieter, and this is where things get kind of interesting. So in a yo-yo dieter, our basal metabolic rate is different. And the reason for that is as you diet, as you drop fat, your body's metabolic rate downgrades. So as you drop weight, you require less, so your basal metabolic rate drops. However, if you keep dieting and going up and down, then you get this adaptation that means you require less calories. And also, because people that are yo-yo dieters tend to be very strict and then bounce back, during their very strict times, their non-exercise activity thermogenesis tends to drop. So if you're restricting your calories quite significantly, your body will regulate the amount of energy you're expending by getting you to move less. And it sounds daft, but when you're feeling incredibly lethargic or you're absolutely exhausted, you will do whatever you can to preserve energy, and you won't necessarily be conscious of it, but you will try and preserve energy, so you basically keep what you've got to just function. So not only does your basal metabolic rate drop as a yo-yo dieter, but also the amount of non-exercise activity thermogenesis you can factor in as well, which is why someone who's a yo-yo dieter traditionally would need less calories. So that gives you a little bit of a feeling about why we're all so different, and it also helps understand why the dieting journey is an experiment and is a bit of a case of trial and error and finding what works for the individual, because we all come from different backgrounds. We all have different things that impact on how many calories we require, and it's definitely not a one size fits all scenario. I hope that's been interesting. I'm not going to go on anymore because I've talked at you for long enough. I hope this has given you a bit of a better understanding on what calories are, how they work, maintaining weight, losing weight, gaining weight, and then what our body uses our calories for. If you have any questions, then as always, just let me know. Otherwise, I will see you next time.